let's look at a very common, simple example of using trig functions. We've got what's called the angle of elevation and the angle of depression. And so very common practical uses of angles. You've got one object related to another, and you might want to often think of you're at one of the points here and you're looking at the other point. And like the cat here is looking at the bird, and you can describe how much that cat has to look up from horizontal as the angle of elevation. That's just that angle upward from the horizontal to some slanty line. Now the bird is looking at the cat, probably a little worried, and the bird can say, well, I'm looking down at something. I wouldn't call it the angle of elevation of my line of sight, but I would still do the same thing. I would compare that the direction that it sees the cat in to the horizontal. The bird would call that the angle of depression. Now notice, the horizontal is always horizontal. Those are parallel lines. And so the angle of depression of the bird looking at the cat is exactly the same. It's congruent, has the same measure. It's going to be 27 degrees here, as the cat looking up at the bird. So sometimes that's a crucial thing, is that you might have something where you're given an angle of elevation, and then you realize, oh, I want to talk about this angle of depression. They're just the same. But where the trig comes in is if you then have you have knowledge of one of the three of these things, the horizontal distance between the objects, the vertical distance between the objects, or the direct diagonal distance between the objects. So here's a simple example. Suppose we know that angle of elevation is 27 degrees, and suppose we know the horizontal distance is 2.3 meters. Then how high above the cat's eye is the bird? And that's going to be important in a sec, the above the cat's eye thing, right? Because it's relative to exactly what this point is, and that happens to be the cat's eye here. So the trig ratio here, we want to know this distance df, and the trig ratio, that's opposite over adjacent. So we just write basically the definition of one of the trig ratios. We say that's called tangent. I don't really need that. Tangent of that angle. Okay, and so df will be 2.30 times tangent of 27 degrees. So this is so incredibly common, is that the actual calculation you do is a certain side times a certain trig function of a given angle. And I'll let it calculate, let me calculate the two pieces. Tangent of 27 degrees is 0.50953. I don't need quite that much accuracy, but we'll leave it in. And then, of course, you're going to multiply those together. And we get, whoops, not where I wanted to do that. So about 1.17 meters. Yeah, maybe, not sure if we might round it to 1.2, given that we didn't know the angle super precisely. But either of those answers are pretty plausible here. So that's a simple example of how you would use this. So a little new terminology, but the main thing is think about which two sides, what side is known, what side is unknown. Think about what trig ratio is appropriate for that. Make sure you know the definition. That's going to be whatever trig ratio, here was tangent of that angle, and that's going to be the actual specific unknown here, the vertical, over the specific known, and then you solve that equation. Now, very often, we would add to that the fact, well, if I want to know how high the bird is above the floor, I want to take into account the fact that the cat's eye is not right on the floor. Maybe it's not too high, maybe it's lying on the floor, but the eye is above. And then that's really easy. That height is just going to be that 1.17 meters plus 0.2. And of course that is just 1.37 meters. So fairly typical thing to just make it a little more realistic. The fact that one of the objects might not be just right at ground level. Now, what about how far is the bird from the cat's eye? So that's going to be CD. Okay. So CD, now that's the hypotenuse. The trig ratios that we've memorized so far, there's names for things where the hypotenuse is in the numerator, but we haven't learned them yet. But we know that we have the one of the most common ones is adjacent over hypotenuse. That's cosine, same angle. And that's adjacent over hypotenuse. One of those is known, one of those is desired. Set up your trig ratio, and you'll be good. Now, that's a little trickier to solve. So you can cross multiply. Well, just multiply both sides by CD. There's no denominator on the right-hand side. And so that's going to be CD times cosine of 27 degrees. And then, so CD now is going to be 2.3 of divided by a cosine. Does turn out that a 1 over cosine has a special name. It turns out it's called the secant, but we won't use that quite yet. But we're ready to go. Just do this in one step. And that's about 2.58 meters. Reality check, it should be longer than 2.3, but not a whole lot longer than the 2.3. Okay. So let's just do one more that focuses more on the angle of depression. So there I need to open up my other one. Oh, no, I don't need to save that. It's already saved. Okay, so here, let me see if I can move everything over. Okay, I do not know why the person drawing this diagram put this little stick figure here, because that's obviously not a person who's going, that's not in good scale with the lighthouse picture. So let me highlight a common mistake here. The picture as drawn had this X and the arrow and this dotted line, and then shaded in this triangle. That's not wrong, but if you shade in this triangle and you think, okay, there's this guy in a boat, there's the top of the lighthouse where the person is going to be looking down, there's the bottom of the lighthouse. The lighthouse is a physical object. It's very reasonable to kind of focus on this triangle. The problem is the angle of depression is by definition the angle from the horizontal, and you want to draw that horizontal as they have done, as a dotted line from the person who's seeing something. So that dotted line is great, but it's then you get this angle that's outside the triangle ABC, and what happens is that people are then very, very motivated to think, oh, this must be the angle I care about because it's the angle in the triangle that I've drawn. So two ways to fix that. One is, don't be afraid to draw more stuff. There's a point hovering in the air above the boat. It's not a physical object, but it's totally geometrically meaningful. Draw this triangle. Now the angle of depression is an angle inside a triangle that you're looking at. That helps a lot, okay? The other thing is you could say, oh, that angle of depression here is the same as the angle of elevation of the guy in the boat looking up. And so it's really this angle. In the triangle ABC, yes, there is one of those angles is the angle X that you're asked about here, but it is not an angle to a vertical. So another way to say it is stop. As soon as you think, okay, I think it's this angle that I'm asked about, ask yourself, is that an angle to a vertical? That is not an angle of depression or of elevation. Okay, so that's a common mistake. So there's another new thing here. I can still draw a trig ratio, but now it's the angle that is the unknown. We're back to adjacent and opposite. That's tangent. And so BE over EA, I'm going to use this triangle that I drew, is tangent of X degrees, some mystery angle X that we, as usual, are going to think about in degrees. Okay. Yeah, because let me put in a reminder, that is opposite over adjacent. Okay. Now, this is known, right? This is 43.2 over 88.5. So we're going to actually calculate that out. Any fraction that we actually have numbers in, we're not going to do manipulations on algebra with. We're actually just going to compute it. Okay. And so let me just simplify it. Tangent of a mystery angle is 0.4814. Okay. And that is where we need to use something a little more sophisticated. That there's a lot of subtle things we can say about, but we usually save for trig precal. And we need, what we need is some sort of machine that does the Jeopardy version. I always like to shout out Jeopardy because of our former faculty member, Jason Zeffirneri. And this is, by that I mean, if I'm going to tell you the answer to a trig output to a trig function, the output of a trig function, a trig ratio, and I'm going to say what mystery angle would correspond to that trig ratio. And that's the very general notion of an inverse function. We'll talk about that more in general in the spring. But this is a really good example. It's like square rooting. It's very analogous. And that is, what is the mystery number whose square is 5? Okay. It's easy for most numbers to square them, but this is a much more sophisticated thing. What is the mystery number whose square is 5? By definition, it's square root of 5, and that's approximately 2.2. Ooh, that's not what I wanted. Approximately 2.2, and you usually have to go to the calculator for these inverse functions. Now we go to the calculator for trig for even the forward operations. So by definition, when you have something like this, I've got a mystery angle, and I know one of these three of our three basic trig functions. I know what the output's supposed to be. I'd say, well, what is the one and only mystery angle that corresponds to that in a right triangle? And that's called, we have this funky notation, which we put a kind of a -1 superscript. That can be super confusing. It looks, if you think about exponents, it looks like it might mean a reciprocal. And I apologize for the confusion. It does not. Let me put that right down. Not a reciprocal, even though it looks like it. It's an overloaded notation. It means undo the tangent. That -1 exponent means, it's a very general thing meaning undo something. And here it means undo the tangent. Great thing here is we don't need yet a lot of sophistication about inverse trig functions. There are some very interesting things you could say. You're going to be able to get that out of the calculator. I'll show you that in a second. And it turns out to be about Nope, that's confusing, sorry. Wrong units. It's like, wait, that's a tiny, tiny number. I forgot. I was going to get this out of, I wasn't going to go to the actual TI calculator emulator. So let's see. So 0.48814. And so what we do is we go second, and above the tangent button is this little tan inverse. You read that as tan inverse. 0.48814. Enter. And then I've got it set in degree mode. You probably will have it in degree mode, but you do need to check. There are other angle modes. About 26.0. Yeah, let's call it about 26 degrees. So let's go back here, and it turns out to be about 26 degrees. Okay. So that's all for that. Plenty long enough on this topic, and we'll practice it in class.